Dear colleagues, let me present you the results of our research named Contextual Concept Meaning Alignment based on prototype theory. This work was done in National University Lviv Polytechnic. First of all, the introduction of autonomous intelligent engines promised to increase the productivity on all parts of economy. Such engines are capable of intentional functioning in natural environments. And if we compare how humans are doing conceptualizations with autonomous intelligent agents, we see that there are certainly a lot of lacking things, such as, for example, the traditional ontological approach lacks the representations of richness, fuzziness, context-dependent meaning of concept, which is typical for human cognition. So in our research, we gained insight from cognitive linguistics, from how humans are processing and conceptualizing knowledge in order to model the contextual dependency of meaning of different contexts. Cognitive linguistics asserts the specific properties of human understanding of context, such as vagueness. So each category can have fuzzy meaning, typicality, but within a category we always select the most typical object to represent the category. Genericity, so we don't pay attention to deviation or exceptions. We always take the most common representative, and opacity that even a professional cannot explain the rules of categorization. And there are two basic principles, such as non-modularism principle and non-objectivist principle. First of one is stating that language cognitive capacity is not located in some specific part of the brain, but it is a part, is the result of all cognitive abilities of human, including visual, kinesthetic skills, conceptualization, categorization. And likewise, the agents, intelligent agents, which are some kind of situation-aware systems, they also obtain, interpret their knowledge from multiple sources, from multiple sensors, from the communication links, from feedbacks from their knowledge base. Non-objectivist principle means that every meaning concept is dependent on user or creator. It's idiosyncrasies, its biases, its stories, narrative, and so on. And this is also true for intelligent agents because they form the meaning of context in the process of making or performing specific task and gaining specific experience. Usually, we model the meaning of concept for intelligent agents using ontology. And currently, we understand ontology as a specification of shared conceptualization. This definition highlights the importance of communication, of sharing, and the common knowledge. However, in real life, the meaning of concept is dependent on the context and the person or agent in which it is used. And with time, the concept becomes fuzzy and becomes having multiple meanings, containing a lot of different nuances, and also it evolves over time. The current research accepts the notion of local agent-specific ontologies, and they are often named contextual ontologies. In order to reuse contextual ontology and share contextual ontology, we use several kinds of formalization languages. For example, OVLC were developed to build bridge rules allowing for mapping between different kinds of ontologies. However, in research, the local about local ontologies does not show how specific concept meanings are acquired, and nor how they are mapped into different usage contexts. So in our research assumption, we state that each intelligent agent creates its own conceptualization of the world, depending on its goal and intent, and constantly updates this conceptualization and knowledge base. And this conceptualization is in a different process always aligned with other agents in their conceptualizations. And this knowledge is tested for consistency. We use prototype theory, which is a central theory of cognitive linguistics, and it says that the meaning of specific meaning of context is represented by a set of prototypes, so the most typical instances of this concept. We propose to represent the meaning of concept with a set of some sort of tree, some sort of local ontology, the ontology of concept, which has a root node. A root node reflects the identity of this context. And we can have several nodes. We have different roles. For example, default, meaning when it is used when usage context is not defined, or reference, which is used to provide the semantic interoperability between different agents, ontologies. And the meaning differentiates of meaning depending on the context. A typical relationship here is a relationship, next mapping relationship, allowing to use knowledge between different interpretation of this concept, and also use it in relationship, which says in which situation and which context this concept is, this meaning of concept is used. Contextual meanings of concepts can be also modeled as a situation aware part of situation aware systems. Typically, when we compare to human cognition has not only semantic memory, which is analog to ontology, but also has so-called situation memory, or so-called episodic memory, which contains information about the situation and context. In our work, we also propose to use the approach of prototype theory to store information about a different typical situation, about typical context, which can be used to find the specific meaning of such or such concept. It is important because each intelligent agent constantly monitors environment and constantly builds the model, the conceptual model of context. So the context for intelligent agents comes first. And we also developed an algorithm method allowing us to find which meaning of concept should be used in a specific situation. We find that proposed approach to model different concept meanings using prototype theory allow us to easily find which concept should be used in each specific situation. And we think that the prototype approach creates a richer, more flexible fuzzy concept model compared to traditional ontological modeling. And it also allows to quickly select the crisp meaning depending on user context. Also, we can add that it also allows us to build new meanings, which is also a substantial advantage. Okay, any questions for me?